This is an example of a limiting reactant product, but instead of the basic level, which is moles to moles, it's the meats level, which is grams to grams. So the first thing I'm going to do is make a quick correction here. This number 5 should be a number 4, so if you will change that on yours. Now, the first thing it says is the heat from an acetylene torch is produced by burning acetylene C2H2 in oxygen. If you have 20.4 grams of C2H2 and 30.4 grams of O2, how many grams of H2O will you produce? So let's start with kind of marking some stuff under our equation that we have and where we're headed. So underneath C2H2, I have 20.4 grams. And underneath oxygen, I have 30.4 grams. And I want to know how many grams of water can I produce? So I'm doing two things. I'm going from C2H2 into H2O and from oxygen into H2O. Alright, first things first, let's start with C2H2. I'm starting with 20.4 grams of C2H2, and I'm going to take a look at my units. The only unit I can currently cross out is grams of C2H2. And the only thing I can turn grams into is moles of the same compound. In my next bracket, I'm going to try to cancel out what's on top of the previous bracket, and so I put it on the bottom. Moles of C2H2. Once I'm in moles of one thing, I can get into moles of another thing, and the thing that I'm trying to get into is moles of H2O. And then, in order to cancel out moles of H2O, I need to put it into grams of H2O. Now I'm going to go through and just make sure all my units cancel out before I put any numbers in. So grams of C2H2 cancels grams of C2H2, moles of C2H2, moles of C2H2, moles of water, which means ultimately my answer should come out in grams of H2O. Alright, now I can put some numbers in. First thing I need is the molar mass of C2H2. And so the molar mass of C2H2 comes from taking carbon plus hydrogen, and I get 26 grams. That's the mass of 1 mole. In my next bracket is where I do my mole ratio. So using the coefficients from my equation, I have 2 moles of C2H2 for every 2 moles of water. And so my coefficients here are 2 and 2. And last but not least, molar mass of water. For every 1 mole of water, it has a mass of 18.01 grams. Now I plug this in my calculator. 20.4 divided by 26 times 2 divided by 2 times 18.01, and I get a value of 14.13 grams. So I can produce 14.13 grams of water if I use all the C2H2 I'm given. What if instead of using the C2H2, I use all of the oxygen instead? Well, let's give it a go. Starting with 30.4 grams of O2. The only unit I have that I can cancel out right now is grams of O2. And grams of O2 can get turned into moles of O2. If I want moles of O2 to cancel, I'll stick it on the bottom. I can go from moles of one compound into moles of another. I'm trying to get into moles of H2O. And once I'm in moles of H2O, and I want to turn it into grams of H2O, now that I have units, let's see that they'll cancel out. Grams of O2, grams of O2, moles of O2, moles of O2, moles of H2O, giving me a final answer in grams of H2O. Now I can put in some numbers. So first things first, for every 1 mole of oxygen, it has a molar mass of 32 grams. If I use the coefficients from my chemical equation, now I'm looking at for every 5 moles of O2, that's a little hard to see there, you get 2 moles of H2O. And so, into my ratio here, in front of the H2O, I can put a 2. In front of the O2 goes a 5. And then last but not least, for every 1 mole of H2O, I have a molar mass of 18.01 grams of H2O. When I plug this into my calculator, 30.4 divided by 32 times 2 divided by 5 times 18.01, I get a mass of 6.84 grams of water. Now, I need to identify what the limiting reactant is. If you think back to before when we defined limiting reactant, the limiting reactant is what it hinders you from producing more product. It runs out first, right? It always produces the lower amount. So when I look at my answers here, the lower amount of product is 6.84 grams of water. That means that my limiting reactant is the reactant that controlled that, which is O2. That means that my excess reactant is C2H2, and my theoretical yield is the amount that I calculated I could make, which is the lowest value, which is 6.84 grams of H2O. Now, regardless of if I had turned it into H2O or CO2, oxygen would limit this reaction either way, right? No matter which product you choose, your limiting reactant will limit both. Now, the part about the Means level that's a little bit trickier is letter C. How much excess reactant remains after the reaction stops? So in order to know how much remains, we need to know how much do we have and how much do we need. So when we're calculating how much excess reactant remains, we need to take the amount that we have minus the amount that we need to give us the amount that is left over. And so to do this, we start with our theoretical yield. So in our case, 6.84 grams of H2O. So this is my theoretical yield, and it's the value that I get when I use all of my oxygen. So now, if this is what we're starting with, and we turn it back into our excess reactant, we can figure out if I'm producing 6.84 grams of water, how much C2H2 do I need to do that? So we set up our brackets. First things first, units need to cancel out. Grams of H2O, moles of H2O, moles of H2O. I'm turning it into now moles of my excess reactant, which is C2H2. And for moles of C2H2, I get grams of C2H2. Now let's double check our units cancel out. Grams of water, moles of water, moles of water, moles of C2H2, moles of C2H2. I'm going to get an answer in grams of C2H2. Now, let's plug some numbers in. For every 1 mole of water, I have the molar mass of 18.01. For every 2 moles of C2H2, I have 2 moles of water. Those are my coefficients for my balanced chemical equation. And for every 1 mole of C2H2, I have a molar mass of 26 grams of C2H2. When I plug it in my calculator, 6.84 divided by 18.01 times 2 divided by 2 times 26 gives me a value of 9.87 grams of C2H2. Now let's label what we have, what we need. Okay? This is going to make it a little bit easier to understand. So this value that you start with, this is what you have, right? What you're given, what you start with. This value that you just calculated is what you need. You need 9.87 grams of C2H2 in order to make 6.84 grams of water. So I take my have minus my need, 20.4 grams of C2H2 minus 9.87 grams of C2H2 to give me what is left over. 10.53 grams of C2H2 is what is left over. Now you try one on your own.